Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in the Department of Computer Science at the Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about the brief overview on spanning trees. So that is the introduction part of this spanning trees. So what is the minimum spanning tree? So minimum spanning tree is nothing but minimum weight spanning tree. It is spanning tree of a connected and directed graph, and is going to be connect all the vertices together with minimum total weights for its edges. So minimum spanning tree is the tree because it is acyclic, and any undirected graph has minimum spanning tree. So which is a union of minimum spanning trees for its connected components. So if a graph has n vertices, then the spanning tree will have n minus 1 edges. So minimum spanning tree or minimum weight spanning tree is the spanning tree of the connector of undirected graph, and it is going to connect all the vertices together with minimum total weight for its edges. And minimum spanning tree is also a tree because it is acyclic, and any undirected graph has minimum cost forest, so which is the union of minimum spanning trees for its connected components. So suppose if a graph has n vertices, then the spanning tree will have n minus 1 edges. So what is a spanning tree first? So given a undirected graph G, and then a spanning tree of the graph is subgraph of the tree that is going to be connects all the vertices together, and a graph has more than one spanning tree, and a unconnected graph has a spanning tree. So for this graph, so what is the spanning tree that is going to be obtained? So that means whatever the edge I'm going to be select, uh, that should not form a cycle, and we have to be visit this all the vertices exactly once. Suppose if I'm going to construct a graph like this, so what are the minimum possible spanning trees I can able to obtain here? So one spanning tree should be like this, and this spanning tree will be obtained like this, and this spanning tree I can also draw like this. So these are the multiple minimum spanning tree that is going to be obtained from this graph G here. Similarly, for this graph, this should be the spanning tree that is going to be obtained. So, what are some of the applications of these spanning trees? So, normally this spanning tree is going to be used in network design, like telephone, electrical, hydraulics, TV cable, and road connectivity, etc. And normally the algorithms should be that and pick hot problem. So, like traveling salesman problem, Stinner tree. Some of the other applications should be maths bottle like cards and LDPC codes for error correction and image recognition, and learning silent features for the real-time face recognition, reducing storage and sequencing amino acids in a protein, and then auto-conferring protocol for internet bridging to over Cytus network, and then cluster analysis. So these are some of the application areas of this spanning trees. So like network design, like telephone, electrical hydraulics, and then approximation algorithm for NP hot problems, like traveling salesman, and indirect applications like max bottling parts, LDPC codes for error correction, like this, and cluster analysis. So these are some of the various applications of this spanning tree. So how this spanning tree is going to be obtained? So the weight of the subgraph is the sum of the weights of its edges, and the minimum spanning tree for the weighted graph is the spanning tree with minimum weight. Like, can a graph has more than one spanning tree? Yeah. So the weight of the subgraph is the sum of the weights of the edges, and minimum spanning tree is nothing but a weighted graph. It should be a spanning tree with minimum weight, and a graph has more than one spanning tree. Let us consider, so this is the graph, and weights are going to be assigned. So in this, what I'm going to say that is, so if I'm going to take the summation of all the spanning tree like this, and minimum weights are going to be considered. So among the first minimum weight, what I'm going to consider is 2, and next minimum weight I'm going to consider 3, and next minimum weight 1 I'm going to consider 3, and the next minimum weight 4. So if I'm going to consider this close octane, so I'm not going to consider this, and next minimum weight is 8, and next minimum weight is 9, and next minimum weight is 14. So if I'm going to consider the loop is going to be octane, so for that I'm not going to select this, and next minimum weight is 50. So like this I'm going to be construct this spanning tree whose weight should be the minimum. So for constructing this also we're going to have different kinds of algorithms. So minimum spanning tree is the tree that is going to be formed from the subset of the edges in a given undirected graph with following properties. So it is going to show the spans of the graph, that is includes each vertex of the graph, and it is the minimum that should be the total weight of all edges should be as minimum as possible. So minimum spanning tree is nothing but a minimum weight spanning tree such that all the sum of the weights of all the edges should be minimum. An example of the problem that is going to answer it is minimum spanning tree. Suppose the problem is several pins of electronic circuits must be connected using at least amount of one. So several pins of this electrical circuit board is available. So I have to connect all these pins. What is the minimum amount of wire that is going to be required here? So for modeling this problem, so the graph is going to be complete undirected graph. So where V should be the set of pins and E should be the interconnection between the plates, and W should be the length of wire that is needed to connect the pair of vertices. So for this I'm going to construct the spanning tree. Okay. So the problem is we're going to have an electronic circuit board. In this one several pins are there. So we have to be connect all this with the least amount of wire. So for modeling this problem, so what I'm going to say that is, so this should be an undirected graph with set of pins, and this should be a set of interconnections, and W will be the length of the wire. So finding the minimum spanning tree. So normally this minimum spanning tree is going to be for two greedy algorithms. So first one is that Driscoll's algorithm, and next one is that Prim's algorithm. So here the Driscoll's algorithm is nothing but we're going to consider the edges in ascending order of cost, and then we have to add the next stage with the tree such that it should not it won't create the cycle. And Prim's algorithm is going to be started with the vertex S and gradually grow tree from S, and each step we have to be find the cheapest edge tree that has exactly one endpoint in it. So Driscoll's algorithm is going to consider the edges in ascending order and add the next edge to the tree until it will create the cycle. And Prim's algorithm is nothing but is going to be start from vertex size, and then it should be gradually follow the tree from S from each step, and the cheapest edge to tree has exactly one end. So this should be the spanning tree that should be constructed using the two algorithms, so Driscoll's and Prim's. So both algorithms should be have different methodology, but eventually end up with the spanning tree only. And the Driscoll's algorithm is going to be uses the edges, and whereas the Prim's algorithm is going to be uses the vertex connection in determining the spanning tree. And in Prim's algorithm, so any instance of the output it represents the tree, whereas the Driscoll's algorithm at any instant it represents the tree or not. So the minimum spanning tree can be constructed by using two algorithms, Driscoll's and Prim's, and both the algorithms differ in the methodology but eventually end up with minimum spanning tree. And the Driscoll's algorithm uses the edges, whereas Prim's algorithm is going to be used the vertex connection. So in Prim's algorithm, any instance of output it represents a Driscoll's algorithm, any instance of output may not represent a tree or not. So what is this Driscoll's algorithm? So Driscoll's algorithm is nothing but a greedy algorithm. So here a greedy is nothing but is going to be choose the local optimum. So that is nothing but picking an edge with their least weight in the spanning tree. And the Driscoll's algorithm should work as follows. So take a graph with n vertices and keep on adding the shortest least edge. So while avoiding the creation of cycles until the n minus 1 edges are going to be added. So sometimes the two or more edges is going to have the same cost. So the order in which the edges are chosen it does not matter, but the difference spanning tree may able to result, but they will have the same total cost, which should also have the minimum cost. So this should be the greedy algorithm. So here this algorithm is going to be choosing the local optimum, so that is the picking an edge with the least cost. And the Driscoll's algorithm should be works as follows. The graph is going to be taken with n vertices and keep on adding the shortest edge for avoiding the creation of cycles until n minus 1 edges is going to be added. Sometimes two or more edges may have the same cost. So the orders in which the edges are chosen doesn't matter, and different spanning tree may able to result but should have the same total cost, which is always the minimum cost. So let us consider an example like this. So this is the graph I taken here. So in this one, I have to construct the minimum spanning tree according to Driscoll's algorithm. So in every step, we have to find picking an edge with the least cost first. So I have to be uh, arrange the edges in decreasing order or increasing order, whatever it may be. So the edges and then cost I'm going to construct. And for this, I'm going to construct one table. So AB edge is 1, AC is 2, BD is 3, BC is 9, and CE is 5, CF is 6, D is 5, and CF is 7, and EF is 6. So these are the edges I noticed initially. Then I'm going to be pick up the minimum edges of the graph. So for the first one is AB, so that one I'm going to be select, and next one is AC, so this one is going to be selected. Next one is BD, so this one is going to be selected, and next one is either DE or CE. I can able to select. So CE is selected, and DE, if I'm going to consider, it is going to form the cycle, so I'm not going to select this. And next one EF or CF, I can able to select. EF, CF is 7, sorry. So EF I'm going to select, that should be 6. And CF, that should be 7 if I'm going to consider. It is going to perform the cycle. And next weight is BC. If I'm going to select, is going to form the cycle. So this one is not going to select. So this should be the final minimum cost, minimum spanning tree. So the sum should be 1 plus 2 plus 3 plus 5 plus 6. So that should be 6, 12, 70. Like this, we are going to be find out the minimum spanning tree from the obtained graph. So the algorithm should work as follows like this. So make a tree, T should be empty, and repeat the steps 3, 4, 5 as long as the T contains n minus 1 edges and E contains not empty. Repeat the steps 3, 4 and then 5. Choose an edge from E of the lowest cost and delete an edge from E, and if this edge does not form the cycle then add it, otherwise you can able to discard it. So if T contains n minus 1 edges then print the spanning number of spanning trees. So the Kruskal's algorithm is that, so initially make the tree should be empty. So what I took initially like this, and repeat the steps 3, 4, 5 as long the T contains n minus 1 edges. So choose an edge with the lowest cost. So in this one I'm going to construct the lowest cost. What is that I'm going to construct? And that one is going to be add on to the tree, empty tree, if it does not form the cycle, otherwise you can able to discard it. So repeat this process until all the edges is going to be constructed from the graph. And next one is the Prim's algorithm. So Prim's algorithm is also a famous greedy algorithm. So normally this is going to be used for finding the spanning tree of the given graph. And to apply this algorithm, so the given graph must be weighted, connected, and then undirected. So normally the Prim's algorithm is going to follow greedy, but the initial constraint should be the weighted, connected, and undirected. So in the spanning tree, any vertex not in the tree but connected with the edge can be added. So to find the minimum cost spanning tree, we must be select. The simple modifier algorithm of the spanning tree is called a Prim's algorithm for finding the minimum cost spanning tree. So the Prim's algorithm is a famous greedy algorithm. So to apply this Prim's, the given graph must be weighted, connected, and directed. And to find the minimum spanning tree, you have to be always add a new edge, which is nothing but as small as possible. And simple modified algorithm is that for finding the spanning tree. So here what I'm going to say that the algorithm, so initially choose a random vertex. So this is the graph what I'm going to be considered here. So from this graph what I'm going to use is, so initially randomly choose a vertex, and the vertex connecting the edge should have at least weight that is usually selected. And second step is that, so find all the edges that connect the tree to the new vertices and find at least each edge among those edges include in the existing tree. If including that edge creates the cycle, then reject that edge and look for the next least weight edge. So find all the edges that connect tree to the new vertices and find the least weighted edge. Those edge include in the existing tree. If the including that edge creates the cycle, then reject the edge, otherwise look for the next edge. So keep on repeating these steps. So how the Kruskal's algorithm, and then finally construct the spanning tree. So in this case, what I'm going to say that is, so take a graph, empty graph like this. Then this is the starting point. So from this, what is the minimum I'm going to select is one. So one is going to be selected, and from here correct the next one. So from B, what is the next minimum? So that should be either 3 I can able to select, or 2 can select, or 5 can select. So that is, this should be 3, and this should be 5, and this should be 2. So among this, I'm going to select the minimum one. So that's why I'm going to select 3 here, 2 here. So B I'm going to be select. And from here, so what is the next minimum? So this should be 3. So 2 is already is there, this 2 already is there. So if I'm going to from E, this should be 2 and 3. So these are the edges that are connected from E. So among these 3, 2. So which one I can able to select? 2 is minimum. So if I'm going to select, is going to form the cycle. So that's why what I'm going to do this, and this one is not going to be selected. And this edge is going to be selected since it is 3. And from here, D. So what are the edges that I have? So this should be 5 and this should be 3 and this should be 4. So these are the edges that are connected from D. So 3 is already there. So next minimum is 2. If I'm going to be select 2 here, it is going to form the cycle. So that's why this edge may not be selected. And if I'm going to select this, it is going to form a cycle, and this one also not going to be selected. And next minimum is 4, so that's why I'm going to select 4. And from C, what are the edges that are connecting? This should be the 5 is there, 5 and 4. So but 4 is already visited. If I'm going to select 5, it's going to form the cycle. So what I'm going to say, this should be the person. So this should be the resultant spanning tree obtained through Primsolver, right? So according to Prim's algorithm, so from the graph, what I'm going to do, I have to choose the initial vertex. From this, I have to find the minimum one. From this, again, I'm going to choose the what is the next minimum. I'm going to find that should be 2. And from here, what is the next minimum? Here it is there, but I'm going to not the selectors. It is going to form the cycle. So that's why I'm going to choose this one. And from here, what is the next minimum? I like this. I'm going to find out the spanning tree. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.